now hopefully it's clear how to find where a function's continuous or not graphically, but what about if you're just given the function algebraically? All right, so a couple things to say. All polynomial functions, so like x squared, x to the third, x to the fifth, those will be continuous everywhere. If you think about what a quadratic function looks like, or cubic function, right? There's no gaps or holes or anything. It's always continuous. If you have a rational function in fractional form, this will be continuous everywhere except where the denominator equals 0. Because remember, if the denominator equals 0, that function is undefined. It'll either be a whole or a vertical asymptote. Radicals, if it's an odd root, like cube root or fifth root, it'll be continuous everywhere. If it's an even root, remember the square root, like 2 or 4, right? So the square root of a negative number is imaginary, so that won't show up on a graph. So it's only continuous where the radicand is not negative. But the key thing to know, right? Polynomials, always continuous. Fractions, everywhere continuous except for where the denominator equals 0. Okay, so here's 2 examples. Which of the following functions is not continuous, not continuous, over the interval from -infinity to infinity? So like all numbers. All right, so this first one's polynomial, x to the fourth, right? So I said that's always continuous, so I know that's not the answer. Okay. I didn't mention this, but trig, so a sine graph looks like this, right? You can see you could draw that without picking up your pencil. There's no holes or gaps or anything. That's always continuous. All right, now we're down to these 2. They're both rational. So somewhere in this denominator, if the denominator equals 0, then the function is not continuous. Okay? This one looks easier to solve. So 1 plus e to the negative x, that equals 0. So that means e to the negative x equals -1. Well, that'll never happen because e to any power is going to be positive. You can't raise e to a power and get a negative number. So this will never equal 0, this denominator, which means that this function will always be continuous. Whereas this, x to the third plus x squared plus x plus 1 equals 0, that's true when x equals -1, right? Because -1 plus 1 minus 1 plus 1 is 0. Right, so this function will be discontinuous when x equals -1. Another example, for which of the following x values is f not continuous? All that matters is where the denominator equals 0. So that's going to be at 2 places, because x minus 2 equals 0 gives us x equals 2, and x plus 1 equals 0 gives us x equals -1. So 2 and -1. Notice they put -3s in there to trip you up because that's in the numerator. The numerator can be 0. 0 divided by a number is 0. That's fine. Just the denominator can't be 0. Okay. All right, for piecewise functions, we need to examine the x value where the rule changes, right? Because this top part's a polynomial that will always be continuous. The bottom part is, but what happens at 0 itself when the rules change? Maybe the limit doesn't exist, or maybe the limit doesn't equal the value of the function. So determine if the function is continuous and justify your answer. So remember, to be continuous, the limit has to exist, the function has to be defined, and they have to equal each other. So let's start with the function, what the value of the function is, because that's simple. So f of 0, we're looking where it's equal to 0, is 0 plus 1, which is 1. All right? Now let's find the limit. The limit as x approaches 0 from the left, because we've got 2 pieces, one from the left and one from the right, and the limit as x approaches 0 from the right. All right, let's consider the left. That's when x is less than 0, so 0 plus 1 is 1. From the right, 0 squared plus 1 is also 1. Therefore, the limit as x approaches 0 altogether is 1. So now we know f of 0 is 1. The limit as x approaches 0 is 1. So now we can say, is the function continuous? Yes, because the limit as x approaches 0 of f of x equals 1, which equals f of 0. So therefore, the function is continuous. All right, let's try another example. Again, let's find the f of first. So f of 1, it'll be where the equal is. It happens to be the top again. So that's 1 squared minus 3. 1 minus 3 is -2. Okay, now let's find the limits. The limit as x approaches 1 from the left, and the limit as x approaches 1 from the right. Okay, from the left, we've got the bottom one. So that's 1 minus 1, which is 0. From the right would be the top one. So that's 1 squared minus 3, which is -2. Oops. Okay, so now the limit from the left does not equal the limit from the right, which means the limit does not exist. So we would say, is the function continuous? No, because the limit as x approaches 1 from the left does not equal the limit as x approaches 1 from the right. Or you could say, maybe, and therefore, limit as x approaches 1 of f of x does not exist. That's an N, D-N-E, does not exist. All right, last one. Okay, this one's a little different. It's piecewise because there's two pieces, but the pieces aren't from the left and from the right. Instead, the pieces are when x is not 4 and when x is 4. So f of 4 is given us straight over here. F of 4 is 15. Now we want to know the limit as x approaches 4. Well, the limit as x approaches 4, we would consider not at 4 itself, but everything around 4. Right? So we'd have to use this top function because we want to see 3.99999 and 4.00001, right? What they're approaching. So we'd use this top function. So we're taking the limit of x squared minus 16 over x minus 4. All right, so if you try plugging in 4, you get 0 over 0, which tells us we need to factor, cancel, then plug in. So factor, that's a difference of two squares, x plus 4, x minus 4. The denominator is x minus 4. Factor, cancel, then plug in 4 plus 4, which is 8. All right, well, the function is defined, f of 4 is 15. The limit exists, it's 8, but the value, f of 4 does not equal the limit as x approaches 4. So is this continuous? I'm going to put it here. No, because the limit as x approaches 4 of f of x does not equal f of 4. And that would be your justification. All right, go ahead and try the next one on your own. And then you can check my answer after. Make sure you got the same thing. All right.